Hello everyone, welcome into another lesson. So today we are going to talk about the unit circle with trig functions. So here you have, of course, the unit circle, and you can visualize this laid over the coordinate plane. So right up in here you have your first quadrant, you have the second quadrant here, the third quadrant here, and the fourth quadrant here. Well, in general, what is true for the first quadrant? X and Y are both positive, so X is positive and Y is positive in the first quadrant, right? No matter what you pick. Now, what about in the second quadrant? Well, your Y is still positive, but this time your X is negative. And then the third quadrant, well, both X and Y are negative. And then in the fourth quadrant, this time you have a positive X value, but your Y is negative. So those are going to be very foundational for understanding the unit circle and how these angles actually work. So let's talk about X and Y's as it relates to the unit circle and how this ties into trig functions. So let's go ahead here. We have functions called the sine, which is abbreviated as sine. We have the cosine, which is abbreviated as the cos. We have the tangent. So from geometry, when you took a geometry course, you were probably very familiar with these. These are the three you're probably most familiar with, the sine, cosine, and tangent. Well, there are three more functions, and all those three are reciprocals of these three. So the reciprocal of the sine function is called the cosecant function. The cosecant is abbreviated CSC, and then the reciprocal of the cosine function is the secant function, which is abbreviated SEC. Then you have the reciprocal of the tangent, which is simply the cotangent function. That'd be abbreviated COT for cot. So and on the left column, you have your original three trig functions, the sine, cosine, and tangent. For the cosecant, you have, on the right side, these are all reciprocals. Cosecant is the reciprocal of sine, secant is the reciprocal function of cosine, cotangent's the reciprocal function of tangent. So what does a reciprocal function mean? Well, cosecant, we're going to use the abbreviations. Cosecant being a reciprocal of sine means it's the same as 1 over the sine. You just take 1 and divide it by the sine, you'll get the cosecant. And it works in reverse. You can say that the sine is the reciprocal of the cosecant function. So 1 divided by cosecant equals the sine, since they're reciprocal functions, if that makes sense. And then let's tie this together with cosine and secant. So you have, of course, actually let's start with secant first. So secant is going to, of course, equal 1 over cosine, since it's the reciprocal of the cosine function. And likewise, the secant, or the cosine, is the reciprocal of the secant. So cosine would equal 1 divided by the secant. So that's how secant and cosine relate. Then, of course, we can relate tangent and cotangent. So cotangent equals 1 divided by the tangent, since they're reciprocal functions. And likewise, then, we could say that tangent's the reciprocal of the cotangent function. So tangent equals 1 divided by the cotangent. That's how those relate. So we've built our foundation. Now, I'm about to bring back something that you all probably, if you haven't had trig in the previous course, if you didn't take it with me or if you didn't have previous exposure, then it's probably been a while since you've seen our two special triangles. You have the 45, 45, 90 right triangles. That looks more like a 30, 60, 90. That's a special triangle also. Let's do a 30, 60, 90 right triangle. So the side opposite the 30-degree angle largely has a side of length of 1. And then you have the side opposite the 60. It's the square root of 3 times longer than the shorter leg, so that would have a length of the square root of 3. Then the hypotenuse would have a length of 2. That's going to be your 30, 60, 90 right triangle. And then you also have a 45, 45, 90 right triangle, which we'll get into that real quick. So 45, 45, 90. So both sides opposite the 45, both legs, both have a length of 1, and the hypotenuse is the square root of 2 times longer than either leg. Both of these can tie together with Pythagorean theorem. You can use that to prove both of those, the 30, 60, 90 theorem and the 45, 45, 90 theorem. Both of those are very important for what we're going to be doing. Okay? So, first let's start with some very basic fundamentals here. We're going to start with your 0 radian, which is also 2 pi. And then we're going to do the 90, which is pi over 2. We'll do the 180, which is pi. Then we'll do 3 pi over 2, which is 270. So everything is going to be based on radius of 1. We're going to base everything today on radius 1 for simplicity's sake. So let's say here this is the full radius 1. So this would be the point, of course, 1, 0, right? Well, at 0 degrees, so at 0 radians, you have the x-coordinate of 1, the y-coordinate of 0. Well, having said that, it's important to understand in general that your x-coordinate corresponds to the cosine of theta. So your x is your cosine. Now, that y-coordinate of 0, your y-coordinate is going to be your sine of theta. So at 0 degrees or 0 radians, or you could even say 2 pi, which is 360 degrees, you end up with a cosine of 0 equal to 1 and a sine of 0 that equals 0. Alright, now we have to delve into the other functions. So x is cosine, y is sine. So why don't we actually start with the reciprocal functions? So let's talk about the cosecant. The cosecant of theta, as we've stated, that's the reciprocal of the sine function. So that's the same as 1 over the sine of theta. And we stated that the sine is the y-coordinate. So that would be 1 divided by y. So 1 divided by y is your cosecant. So your y-coordinate's 0. Well, 1 divided by 0 is undefined, right? So your cosecant, in this case, of 0 is actually undefined. We don't get a value for the cosecant. Now let's talk about the secant. So in general, the secant of an angle, we'll call that angle theta. That's the reciprocal of the cosine. So that's 1 divided by the cosine of theta. which of course is going to equal 1 divided by x. Now, at 0, your x-coordinate is 1, right? So, 1 divided by 1 is 1. So in this case, the secant of 0 also equals 1. So we've talked about cosine, sine, we've talked about cosecant and secant. Now we need to talk about tangent and cotangent. So a nice trick for tangent, the tangent of an angle, tangent of theta, is the same thing as the sine of theta divided by the cosine of theta. Those are very fundamental identities. Well, what is the sine of theta? That's the same as your y-coordinate, right? Divided by your cosine of theta, which is your x-coordinate. So that's y divided by x. Now, what is your y-coordinate? That's 0 divided by 1, you get a tangent of 0. So the tangent of 0 also equals 0. And then last but not least, we have to consider the cotangent. So the cotangent of theta, that's definitely the reciprocal of tangent. That's 1 divided by the tangent of theta, which the reciprocal of tangent, that would be the same as the cosine of theta over the sine of theta, which the cosine is our x-coordinate, the sine is our y-coordinate. So this would be x divided by y. So you could just take 1 divided by 0, you would get an undefined expression. So the cotangent at 0 is actually also undefined. So at 0 and 2 pi also, because they're both at the same angle, it's just a full revolution around the circle to the exact same spot, you have a cosine of 0 being 1 and the sine of 0 being 0. From there, you can build up all other 4 functions if you understand what those identities are. Okay. Now, let's go ahead and go for pi over 2, which is the same as 90 degrees. So radius 1, we'll say, is up here. So at 90 degrees, which is pi over 2, what would that be in xy units? That would be 0, 1, right? That would end up being 0, 1. We've already stated that your cosine is going to be your x-coordinate, so that means the cosine of pi over 2 actually equals 0. And then we can state that the sine is your y-coordinate, so the sine of pi over 2 is equal to 1. Alright, from there we can define the other 4 functions. So let's look at the secant. Well, secant of pi over 2, isn't that going to be the same thing as 1 divided by the cosine of pi over 2? Well, that would be 1 divided by 0, which would actually make that completely undefined. So the secant of pi over 2 is actually not defined. Then we can talk about the cosecant of pi over 2. So let's deal with the cosecant of pi over 2. Well, that's going to be the same as 1 over the sine of pi over 2. Well, what is the sine of pi over 2? That's 1. That'd be 1 divided by 1, which would therefore render your cosecant being 1. So the cosecant of pi over 2 equals 1. And then from there we need to find the tangent. Alright, so the tangent of pi over 2 is going to equal then of course that's the same as the sine of pi over 2 divided by the cosine of pi over 2. Well, the sine of pi over 2 is 1, the cosine was 0, you get 1 divided by 0. So the tangent at pi over 2 is actually undefined. And then, of course, last but not least, we have the cotangent of pi over 2. So to find the cotangent of pi over 2, that's the same as taking the cosine of pi over 2 and dividing it by the sine of pi over 2. Which, of course, would give you 0 divided by 1, which would just give you 0. So the cotangent of pi over 2 is going to be 0. Alright, so there's all that. So next we're going to talk about pi. So, and we know from yesterday's lesson, pi is the same as 180 degrees. If we go radius of 1 out and we plot our point, we'd be at the point -1, 0, right? So that would be -1, 0 for my coordinates. Well, we've already stated that the x-coordinate is your cosine of that angle, so the cosine of pi, in fact, would equal -1. And then your y-coordinate is your sine, so that means the sine of pi is going to equal 0. So now let's get into the secant of pi. So the secant of pi, that would be the same as 1 over the cosine of pi, which is going to end up being 1 divided by -1, which means the secant of pi is simply -1. Alright, now, what about the cosecant of pi? That's the same as 1 divided by the sine of pi, which would give you 1 divided by 0, that's undefined. So the cosecant of pi is actually undefined. Alright, now, let's get into tangent and cotangent. So, the tangent of pi is the same thing as the sine of pi divided by the cosine of pi. Well, sine divided by cosine, so that's going to be 0 divided by -1, which would end up giving you 0. So the tangent of pi is going to end up giving you 0. And in this case, for cotangent, we can take the easy way out and say it's 1 divided by tangent, which is the same as cosine over sine. It doesn't matter how you want to spin it, you're going to get the same answer. Cotangent of pi is 1 divided by the tangent of pi. That's going to, of course, equal 1 over 0, which actually gives us an undefined value. So the cotangent at pi actually comes up undefined. So there's all your values for the special angle pi. Now let's talk about 3 pi over 2. Alright, so 3 pi over 2, which is 270 degrees. Alright, well, if I plot my point down here of radius 1, if that's the xy axis, where does that put me? That puts me at 0, -1, right? I'm at the point 0, -1. Well, my cosine's always my x-coordinate, which means my cosine of 3 pi over 2 is going to end up equaling 0. And then my sine's my y, so that means the sine of 3 pi over 2 would actually be -1. Okay, so now we can go from here and find our special values. So we find the other 4 functions. So the secant of 3 pi over 2, well, that's just equal to 1 divided by the cosine of 3 pi over 2, right? Well, that's just going to give you 1 over 0, which is undefined. So the secant at 3 pi over 2 would actually be undefined. Now we can deal with the cosecant. So the cosecant of 3 pi over 2, that's the same as 1 divided by the sine of 3 pi over 2, which would give you 1 divided by -1, or simply -1. So the cosecant at 3 pi over 2 also would be -1. Alright, then we'll do the tangent and cotangent. Last but not least, the tangent and cotangent. So the tangent of 3 pi over 2, that of course is the same thing as the sine of 3 pi over 2 divided by the cosine of 3 pi over 2. Well, the sine we determined was -1, the cosine was 0. Well, -1 divided by 0 is actually undefined. So the tangent of 3 pi over 2 actually ends up being undefined. Now, then we have the business of the tangent. I'm sorry, the cotangent, excuse me. So the cotangent of 3 pi over 2 is the same as the cosine of 3 pi over 2 divided by the sine of 3 pi over 2. The cosine was 0, the sine was -1, well, 0 divided by -1 is 0. So the cotangent of 3 pi over 2 is equal to 0. So those are your 4 main angles right on the axes. Now, you're probably wondering, so where do these 45, 45, 90, and 30, 60, 90 triangles come in? I'm glad you asked. I'm very glad you asked that, because we're about to cover all the other special angles. So, you may remember from geometry or any other previous trig experience, if you had it, you might remember the saying, so, ka, toa. So, ka, toa. So, the so part means sine is opposite over hypotenuse. So if I want to take the sine of this 30-degree angle, it's the leg opposite the 30 degree divided by the hypotenuse. So that would give me the sine of 30 is 1/2. Now, ka, that means cosine is the adjacent leg over hypotenuse. So let's look at that same 30-degree angle. If I wanted to take the cosine of 30 degrees, I would take the adjacent leg, which is the square root of 3, and divide that by the hypotenuse. So the cosine of 30 is the square root of 3 over 2. And then the tangent. The tangent is going to be opposite over adjacent. Toa, opposite over adjacent. So if I wanted to take the tangent of 30 degrees, I'm going to take the opposite leg of 1 divided by the adjacent leg of the square root of 3, which we know would rationalize into the square root of 3 divided by 3. So, and it's still true that you have the reciprocal functions. So if you understand that the cosecant's the reciprocal of sine, the secant's the reciprocal of cosine, the cotangent's the reciprocal of tangent, you would just switch it around to where So let's say we want to talk about the cosecant. So CHO. The cosecant would be hypotenuse over the opposite leg. The secant, so that would be cho-sha. So secant is hypotenuse over adjacent. And then cotangent, CAO. Cho-sha-cow. So katoa cho-sha-cow. So you would have the cotangent is the adjacent leg over the opposite leg. And we'll get into all that here in a minute. So why don't we start with 30 degrees? So the pi over 6. So to find your xy coordinates, let's deal with pi over 6. Now, what is the sine of pi over 6? This might actually, or actually, let's look at the cosine of pi over 6. So the cosine of pi over 6, that's 30 degrees, that's the adjacent over the hypotenuse, that's going to be the square root of 3 over 2. And of course, this is all still radius 1, we'll plot that point there. And now, what's the sine of pi over 6, or the sine of 30? Opposite over hypotenuse, that'd be 1/2, right? So that means your xy coordinates would be the square root of 3 over 2, then 1 over 2. That would be your ordered pair that corresponds to pi over 6. Now from here, we can develop the secant and cosecant. So the secant of pi over 6, that of course is the reciprocal. That would be the same as 1 divided by the cosine of pi over 6. Well, the reciprocal of the square root of 3 over 2 actually equals, that would be 2 times the square root of 3 over 3 by the time you rationalize the denominator. No, I'm sorry, that's wrong. 2 divided by the square root of 3, so, no, actually that's right. So you would get a secant equal to 2 times the square root of 3 over 3. Alright, so the cosecant should be pretty straightforward. So the cosecant of pi over 6, well, that's the same as 1 divided by the sine of pi over 6. Well, that's 1 divided by 1/2, right? 1 divided by 1/2 just gives you 2. So the cosecant is going to end up being 2. Now we can find the tangent. So the tangent is going to be your opposite over adjacent. I'm sorry, that's not right. Your opposite over adjacent, rather. Yeah, opposite over adjacent. So that would be 1 over the square root of 3, which would turn into the square root of 3 over 3. And then now, of course, we can find the cotangent by taking 1 divided by the tangent of pi over 6, which would be 3 over the square root of 3. That's the reciprocal of square root of 3 over 3 would be 3 divided by the square root of 3, which would just simply turn into the square root of 3. So the cotangent of pi over 6 equals the square root of 3. Really, if you can understand cosine and sine, the other 4 aren't so bad to deal with. Cosine and sine are your absolute foundations. Alright. Let's deal with pi over 4. Let's deal with pi over 4. So, pi over 4 is the same as 45 degrees. So let's find the cosine. The cosine's your x-coordinate, of course, but the cosine of 45 adjacent over hypotenuse, that's 1 over the square root of 2, which is the square root of 2 over 2. So we have, for your x-coordinate, the square root of 2 over 2, and then for your y-coordinate, which is the sine of pi over 4, that's going to be the opposite over hypotenuse. You get the exact same thing, the square root of 2 over 2. So you'll have your ordered pair, your cosine's your x, so you'll get the square root of 2 over 2. Your sine's also, or your y is also the square root of 2 over 2. That would be your ordered pair. All right. From there, we can find the secant and cosecant. So the secant of pi over 4, that's just going to end up equaling 1 divided by the cosine of pi over 4. Well, so 1 divided by the square root of 2 over 2, that turns into 2 divided by the square root of 2, which when you rationalize all that, you would just end up getting the square root of 2. So the secant of pi over 4 just turns into the square root of 2. And actually, you're going to get the same thing with cosecant, because it's going to end up being the reciprocal of the sine, which was the same thing in this case. The sine of pi over 4 is actually the same thing as the cosine, so you'll end up just getting the square root of 2. So the cosecant also equals the square root of 2. Now, let's see. From here, let's find tangent and cotangent. That's actually not going to be so bad. Not as bad as you think. The tangent of pi over 4, again, the sine of pi over 4 divided by the cosine of pi over 4. Well, the sine's the square root of 2 over 2. The cosine's the square root of 2 over 2. You divide any number by itself, you just get 1. So that means the tangent of pi over 4 in this case is just simply 1. Dang it. The tangent's 1. And then it's pretty easy for the cotangent because it's just the reciprocal of the tangent. The tangent, see, so the reciprocal of 1 is just 1. So the cotangent in this case also equals 1. Alright, let's do pi over 3. This is going to build the foundation for the other quadrants. There's going to be a little bit of a shortcut so we don't have to do as much work when we get to the other quadrants. So, let's do pi over 3, which is the same as a 60-degree angle. Now, let's deal with the cosine because that's going to be our x-coordinate. The cosine of an angle, the cosine of 60 is your adjacent leg over the hypotenuse, so that would actually be 1/2. Now your sine, that's always the opposite over hypotenuse. That's going to be the square root of 3 over 2. So that means for an xy coordinate, you'll have 1/2 for your x, the square root of 3 over 2 for your y. So that's what that plotted point would be, 1/2 square root of 3 over 2. Okay. From here, let's build the secant. The secant of pi over 3, that's the same as 1 divided by the cosine of pi over 3. Well, what's 1 divided by 1/2? That's just 2, right? So that means the secant is just going to be equal to 2. Alright, let's deal with cosecant. This one won't be quite as nice. So the cosecant of pi over 3 is the same as 1 divided by the sine of pi over 3. Well, the reciprocal of the square root of 3 over 2 is 2 over the square root of 3, which turns into 2 times the square root of 3 over 3. So the cosecant of pi over 3 equals 2 times the square root of 3 over 3. And then last but not least, we have the tangent and cotangent. It might honestly be easier just to look at our triangle. So the tangent of an angle is the opposite leg over the adjacent leg, which would just give you the square root of 3. So the tangent is going to just be the square root of 3. Now, the cotangent's always the reciprocal of the tangent. The reciprocal of that is 1 divided by the square root of 3, which would be the square root of 3 over 3. So the cotangent equals the square root of 3 divided by 3. So those are, in general, how you find those. Now, we talked at first about how x and y are both positive, right? So that means your cosine is positive, your sine is positive, which by extension means your secant is positive, your cosecant is positive, your tangent is positive, and your cotangent is also positive. All those are positive in the first quadrant. Now, yesterday we talked about reference angles in the lesson. So once you get to something like 2 pi over 3 or 3 pi over 4 or 5 pi over 6, that 2 pi over 3, if you subtract that from pi, is treated just like a pi over 3, which would be a 60-degree angle. Well, so here's the point plotted at radius 1. Let's take 2 pi over 3. Now, what is true in the second quadrant for your x-coordinate? In your second quadrant, your x-coordinate is always negative, right? So the cosine, you're going to treat this just like you would a 60-degree angle, only you're going to put a negative sign on it because you're in the second quadrant. So the cosine of 60 is going to be adjacent over hypotenuse. It would normally be 1/2, but since it's in the second quadrant, you'll actually end up getting negative 1/2. And then what about your sine? Well, the sine's your y-coordinate, right? In the second quadrant, your y is still positive. So for the sine of 60, you would get the positive square root of 3 over 2. So you're going to have an xy ordered pair of negative 1/2 positive square root of 3 over 2 at 2 pi over 3. Now your tangent, so the tangent, that means it's normally sine over cosine, right? Well, positive divided by a negative gives you a negative. So a positive divided by a negative gives you a negative. That means you can find the tangent of 60 and you'll just put a negative sign on it. So the tangent's opposite over adjacent, so that'd be negative square root of 3. So the tangent would be equal to negative of the square root of 3, which means then your cotangent, that's adjacent over opposite. Since it's going to be, in this case, x over y, you would have a negative divided by a positive, which is a negative. You would just get negative of the square root of 3 over 3. All right. Now, we also have, of course, the secant and cosecant. So to find the secant, that's just, of course, the reciprocal of the cosine. So if your cosine's negative, that means your secant's going to be negative. So the reciprocal of negative 1/2 is negative 2. So you get a secant of negative 2. Then you can find your cosecant by taking the reciprocal of the sine. Well, if your sine's positive, that means your cosecant will be positive. So the reciprocal of the square root of 3 over 2 turns into 2 times the square root of 3 over 3. So that's how it's starting to work once you get into the second quadrant. Alright, so let's do 3 pi over 4. Let's take care of 3 pi over 4. Let's plot that. So 3 pi over 4, that means it's in the second quadrant, so your x is negative, but your y is positive. So your cosine of 3 pi over 4, that's a 45-degree angle. So you're going to take the cosine and then put a negative sign on that. So adjacent over hypotenuse, that would end up turning to negative of the square root of 2 over 2. And then, of course, you have the sine, which is your y-coordinate. Well, the sine is positive in the second quadrant, so that would be opposite over adjacent. That would be positive square root of 2 over 2. So your xy coordinates are negative square root of 2 over 2, then positive square root of 2 over 2. Alright. Now, we have, of course, we need to find the secant and cosecant. So if your cosine is negative, your secant will certainly be negative. Secant, of course, of 45, that's going to be hypotenuse over adjacent. That would end up being negative of the square root of 2. And then if your sine is positive, that means your cosecant will also be positive. So that's going to be hypotenuse over opposite. You would get positive square root of 2. And then you can find the tangent. Okay. Tangent, right, is sine over cosine, isn't it? That means if you take a positive divided by a negative, you'll get a negative. So opposite over adjacent, that would be 1. Then you throw a negative sign on there. So the tangent of 3 pi over 4 is negative 1. And cotangent is just reciprocal of tangent, so you'll also get a cotangent of negative 1. Alright, let's do 5 pi over 6. So 5 pi over 6, that's the same as a 30-degree angle in the second quadrant, or pi over 6 located in the second quadrant. So in the second quadrant, your x is negative, which means your cosine will be negative. So now find the cosine of a 30-degree angle adjacent over hypotenuse, and throw a negative sign on there. You would get negative of the square root of 3 over 2. Now find the sine, which is actually going to be your y-coordinate. Well, the sine in the second quadrant is still positive, so opposite over adjacent, that would give you positive 1/2. So your ordered pair would be negative square root of 3 over 2, positive 1/2. Alright, so now let's find the secant of 5 pi over 6. Well, if your cosine's negative, so will your secant be negative. That's going to, of course, be hypotenuse over adjacent. So that would be negative 2 times the square root of 3 all over 3. Then you can find the secant, or the cosecant rather, for the sine. That's if your sine is positive, your cosecant also will be. Reciprocal of 1/2 is positive 2. And then we can find tangent and cotangent. So tangent, of course, is sine divided by cosine. So a positive divided by a negative gives you a negative. So the tangent would be opposite over adjacent, which would end up giving you, in this case, negative of the square root of 3 over 3. And then the cotangent's the reciprocal of the tangent, so that's also going to be negative. You'll end up getting negative, so that'd be adjacent over opposite. You'll just have negative of the square root of 3 for your cotangent. Alright, so in general now, we can say the cosine is negative in the second quadrant because your x is negative. Your sine's still positive because your y is positive. So that means your secant's negative because your cosine's negative. Your cosecant is positive because your sine's positive. Now, tangent, of course, would be negative, and cotangent would be negative. So now let's move to the third quadrant. You'll find something very interesting with tangent. Alright, so let's deal with 7 pi over 6. That's the same as a 30-degree angle in the third quadrant. So 7 pi over 6. Alright, well, let's find the cosine of 7 pi over 6, which is going to be a 30-degree angle that's negative. So the cosine of 30 is adjacent over hypotenuse, so that'd be negative square root of 3 over 2 since we're in the third quadrant. And then your sine would also be negative because you're in the third quadrant. The sine of 30 is 1 over 2, but put a negative sign on there, you would get negative 1/2. So the ordered pair would be negative of the square root of 3 over 2, negative 1/2. Alright, now let's find the secant. So since your cosine's negative, your secant also will be. Secant is going to be hypotenuse over adjacent, so that'd be negative 2 times the square root of 3 all over 3. And then your cosecant, well, if your sine's negative, your cosecant will be, the reciprocal of negative 1/2 is negative 2. Now, something very interesting about your tangent and cotangent. Tangent, again, is sine divided by cosine. Well, a negative divided by a negative is actually a positive. So the tangent of 30 is 1 divided by square root of 3. That's actually going to give you positive square root of 3 over 3. And then cotangent's just the reciprocal of tangent. If your tangent's positive, so is your cotangent. So adjacent over opposite, that'd be positive square root of 3. In fact, I think we kind of get the idea with this. So, in general, in the third quadrant, because your x is negative, your cosine's going to be negative. Your sine will also be negative because y is negative, which means your secant's negative, your cosecant is negative, but your tangent and your cotangent actually end up positive. So very interesting how that works. Let's do an angle in the fourth quadrant to close this out. So let's do 7 pi over 4. That's in the fourth quadrant. So let's go here. Now notice, in the fourth quadrant, what's true about x? X is actually positive, but y is negative. So let's deal with 7 pi over 4. Alright, so find your cosine, which is your x-coordinate. If your x is positive in the fourth quadrant, you'll just find a straight up cosine of 45. Adjacent over hypotenuse, that would be positive square root of 2 over 2. And then your sine, you're in the fourth quadrant, your y would be negative. So the sine of 45 is opposite over hypotenuse, and then throw a negative sign on there, you get negative of the square root of 2 over 2. So the ordered pair that represents that would end up being positive square root of 2 over 2, the negative square root of 2 over 2. Alright, so then from here, let's find the other four functions. Let's find the reciprocal of cosine, which is secant. The secant's going to be positive since the cosine is. Well, that's hypotenuse over adjacent. You'll get positive square root of 2. But your cosecant, on the other hand, since your sine is negative, your cosecant's also going to be negative. So that's going to be hypotenuse over opposite. Then just throw a negative sign on there. You'll get negative of the square root of 2. And then tangent and cotangent. Well, tangent is sine over cosine. A negative divided by a positive is a negative. So for your tangent, just find the tangent of 45 and throw a negative sign on there. So that would be opposite over adjacent. 1 over 1, then that would just be negative 1. And then cotangent's the reciprocal of tangent. Reciprocal of negative 1 is also negative 1. So in general, then, we can say that the cosine of the fourth quadrant's positive because the x is positive. Your sine is actually negative this time, which means your secant's going to be positive, your cosecant will be negative, then your tangent's negative, and your cotangent's negative. So your tangent and cotangent are only positive in the first and third quadrants, and they're negative in the second and fourth. Kind of weird how that works diagonally, but that's how it works. So there's even a stronger point to this. Now, we can talk about even and odd functions also. So let's keep those up a minute, all right? So let's say, for example here, let's just do this. So even functions, we have the cosine of negative x equals the cosine of x. So if you take the cosine of negative x, that's equal to just the cosine of x. Or you could make that negative theta would equal the cosine of positive theta. Okay, so let's say, for example, I took the cosine of negative pi over 4. Well, what is negative pi over 4? That's the same as pi over 4, only in the fourth quadrant, right? Because I'm going clockwise as opposed to counterclockwise. So that would prove then my cosine is still positive. That would still equal the cosine of pi over 4. And then by extension, your secant function's also even for the fact that it's the reciprocal of the cosine. So both cosine and secant are even functions, and of course an even function definition, no matter what type of function it is, if you take f of negative x, if you put negative x in for your function, you should get back plain old f of x. So cosine of negative x equals cosine of x, secant of negative x equals secant of x. So those are even functions. Now, let's talk something also about, let's say we have odd functions here. Let's start with sine. So if I took the sine of negative x, I'm going to get negative of the sine of x. So of course, definition of an odd function is if you take f of negative x, you'll get the negative of f of x. So let's do the same thing here then as the sine of negative pi over 4. And you can do this with any angle. I'm just using negative pi over 4 to make this easy. So sine of negative pi over 4, well, that negative pi over 4 puts me in the fourth quadrant, right? That's like a 45-degree angle in the fourth quadrant, and my sine is negative. So therefore, we could say sine of negative pi over 4 equals negative of the sine of pi over 4. It works the exact same way. Which then by extension, because of my sine, that means my cosecant function is also odd. And then, well, tangent and cotangent are also odd functions because tangent is simply sine divided by cosine, cotangent's cosine divided by sine, and so tangent of negative x would be odd. It would become negative tangent of x, and then the cotangent of negative x would equal negative of the cotangent of x. Okay, so it's important to remember, if you remember nothing else, cosine is even, and then by extension secant's even, all the other four are odd. That's going to help you out, and we use it all the time, even in calculus. That's a very important one. We'll even use it some in this course when we do trig identities and some of the proofs with that. So, very important. All right. What else did I want to cover? All right, I think we get the unit circle enough here. We're not terribly far from done, but in fact, I'm even going to erase these because we won't be doing conventional stuff now. So let's say we're going to do some even and odd functions. So let's say the sine of an angle t. Now let's just use theta. Let's say the sine of theta equals 1/3. The sine of theta equals 1/3. They want you to first find the sine of negative theta. So what is the sine of negative theta? We've determined that's an odd function, so that's going to be the exact same thing as negative of the sine of theta, which would give you negative 1/3. Now to find the cosecant of negative theta, because they also are asking you that, that's the same as the negative of the cosecant of theta. Well, what is the cosecant of theta? Reciprocal of sine, that would be the negative of 1 divided by 1/3, which would end up giving you negative 3. So there's an odd function at work for you. All right. Now we have the cosine of theta equals negative 3 pi over 4. Cosine of theta equals negative 3 pi over 4. Let's find the cosine of negative theta. Well, cosine's an even function, so that just turns back into the cosine of theta, which would just again be negative 3/4. Now let's find the secant of negative theta. So the secant of negative theta, that's the same as just the secant of theta, and the reciprocal of negative 3/4 would end up being negative 4/3. So the secant of negative theta would become negative 4/3. Easy enough, right? Okay, now let's do something else here. Let's say, because trig functions are also periodic, trig functions are in fact periodic, which we will talk more about that as we get into graphing of them. But the sine of theta equals 4/5. Well, so let's say here I want to find the sine of theta plus pi. So now I'm adding pi to my angle. So let's say I had if this were some angle in the first quadrant, I add pi, that's going to put me in the third quadrant, right? Or heck, the angle's in the second quadrant, still a positive sign. I add pi, I'm going to end up in the fourth quadrant, right? I'm going to end up halfway around the circle. Well, that is going to be the same thing as negative of the sine of theta. So for a sine function, adding pi can radically make this a negative, which would end up giving you negative 4/5. Alright, now let's talk about something else. Let's talk about the sine of pi minus theta. This is an interesting concept. So we have some angle here. Now, if it doesn't really matter in this case, you have the sine of, let's say, some angle in the second quadrant. You subtract that from pi, you'll be in the first quadrant. If you have a first quadrant angle, you subtract that from pi, you'll be in the second quadrant. So in reality, it really doesn't matter then which quadrant you end up in. You'll end up with the original sine of theta, which would just give you 4/5. Alright, so that wasn't so bad. Now one more of these. This time let's say the cosine of theta equals 4/5. Cosine, all the trig functions are periodic. Let's say we have the cosine of theta plus pi. So, in this case, it would either be in the first or fourth quadrant, right? Because the cosine is only positive in the first or fourth quadrant. Well, let's add pi. If it's in the first quadrant, that'll put you in the third, which would negate that. If you're in the fourth quadrant, that would put you over in the second, which would also negate your cosine. So if you add pi, this is going to be the same thing as negative of the cosine of theta, which would end up giving you negative 4/5. Alright, now, what about one more here? Let's just do one more. You would have the cosine of pi minus theta. What the heck's going to happen there? So, the cosine is positive in the first quadrant. Well, if I take pi and I subtract a first quadrant angle, I get a second quadrant angle. Heck, let's say I'm even in the third quadrant, alright? Let's say I'll even make the angle negative, which is in the fourth quadrant. So you have pi minus negative pi over 4. That would give you pi plus pi over 4, which would give you 5 pi over 4. That would negate that because you would be in the third quadrant. So either way, this also is going to turn into negative of the cosine of theta, which would actually end up giving you negative 4/5. So very interesting how these periods work. Alright, one more set of exercises I would like to do. So this time, we're going to be given some arbitrary angle. It's our job to find the value of the 6 trig functions. Don't even pay attention to your angle markers here. We're just going to plot the point at the end of the radius. That point is going to be negative 8/17, 15/17, which would correspond into the second quadrant. So that could be any angle, but the radius is 1. That's good news here. Radius is 1 for today. This is just some angle theta. Well, if the radius is 1, this is going to make our lives a lot easier. So in this case, the sine of theta, that's just going to be our y-coordinate. That'd be positive 15/17, right? The cosine's your x-coordinate. That's just going to be negative 8/17. So we've already found two of the trig values. Now from there we can easily find the secant and cosecant, because the cosecant's the reciprocal of the sine. The reciprocal of 15/17 would be 17/15. Now the secant's the reciprocal of the cosine. Reciprocal of negative 8/17 is negative 17/8. And then, of course, we can find the tangent. That's the same as the sine over cosine, which would end up being 15/17 all over negative 8/17, which would end up turning into 15/17 times 17 over negative 8, which would give you a value for your tangent of negative 15/8. In fact, let me mark these. And of course, this works very nicely if your radius is just 1. Now the cotangent's just the reciprocal of the tangent, so the reciprocal of negative 15/8 would be negative 8/15. So that one wasn't so bad. Let's do a few more like this. Alright, we're going to be given another angle here. We don't really know if that's pi over 6. I'm just kind of plotting it on the unit circle to help us. Here's our theta. So the coordinates here are going to be 12/13, 5/13, with a radius of 1. That makes our lives easier. Radius of 1, okay? So what is going to end up then? Our sine's the y-coordinate, right? The sine of theta in this case is going to be 5/13. That one wasn't so bad. That's just your y-coordinate. If you had any other radius other than 1, there's a way to deal with that, which we'll talk about in a couple lessons from now. But the cosine of theta, that is going to be your x-coordinate. That would be 12 over 13. So from here, we can easily find the secant and cosecant. So the cosecant of theta, that's the reciprocal of your sine. Reciprocal of 5/13 is 13/5. Alright, and then we have the secant of theta, which is the reciprocal of the cosine. Reciprocal of 12/13 is 13/12. And then tangent of theta, that's sine divided by cosine. So tangent of theta equals 5/13 divided by 12/13, which is going to end up equaling 5/13 times 13/12, which would just end up giving you 5/12. So the tangent of theta would be 5/12, and then the cotangent of theta is just the reciprocal of your tangent. Reciprocal of 5/12 would actually just be 12/5. Let's do one more. Just one more, then we're done. Alright, what do we got here? Good one. So, we're going to be down in the third quadrant. So there's your angle theta. We have the coordinates -4/5, -3/5. Still with radius of 1. Let me get another marker because I think I'm running out of ink. Alright. So the sine of this theta is your y coordinate, which would be -3/5, right? So the sine of theta would equal -3/5. That's easy enough. Now what about the cosine? That's your x coordinate, so that would be -4/5. Alright, so from here we can easily find our cosecant of theta, which is the reciprocal of sine. The reciprocal of -3/5 is actually -5/3. You can also find the secant of theta because that's the reciprocal of cosine. The reciprocal of -4/5 is -5/4. Now the tangent of theta, that's going to be the sine divided by the cosine. So the sine is -3/5 divided by -4/5, which would turn into -3/5 times 5 over -4. That's actually going to give you +3/4. And that makes sense because we're in the third quadrant. You would in fact get a positive tangent. And then the cotangent of theta is just the reciprocal of the tangent. Reciprocal of 3/4 is 4/3. So that was all for radius 1. So that's it for the unit circle and basic introductory trigonometry. Next lesson we're going to get into some right triangle trigonometry. So I hope everyone has a great day. Take care.